And now 2.2 part 3. So piecewise functions are next on the menu. These are just functions that are defined in pieces. Look at this absolute value function, for example. Remember how whenever we learned what the absolute value function looks like, it's like this, where this is your x-axis and this is your y-axis. So for an absolute value function, for all your positive x values, you have this side of your function. So they defined this side of the function as this. It's equal to whatever x is equal to, y is also equal to that. Then they defined the negative side, like this. So what this means is, for every x that's negative, if you take the opposite of it, that's what your y value will be. That's how they got this definition. So if you were just given this particular function, this is how you would work it. Look at your x value, which is -4. Figure out which of these two intervals the -4 falls into. Well, -4 falls into the green one. It falls into the second interval because it's less than 0. So you plug the -4 into this part of the function, negative x, but x is -4. So negative of a -4 is a positive 4. Well, where does -2 fall? -2 also falls into the green part because it's less than 0. So negative of a -2 is equal to 2. But where does 0 fall? It doesn't fall in the green one, but this one says x is greater than or equal to 0. So 0 falls in the yellow one, as does 2 and 4. So if you were to plot all of these, you would get 0 falls into this one, so whatever x is, that's what y is. That's just 0. You put 2 right there, f of x equals to 2, so that's just 2. If you put 4 in this interval, x is 4, so y is 4. Now let's plot these points. -4, 4, -2, 2, 0, 0, 2, 2, 4, 4. Oh, that's supposed to be a straight line, okay? So this is your absolute value function. The domain would be all real numbers. The range would be 0 to infinity. So the key to piecewise functions is just looking at your x values and determining which interval it falls into. Once you figure that out, you put the x into the function itself, which would be this part. This is the function, and the circle would represent the intervals that the x belongs to. Let's look at another one. Sometimes it's a little bit easier whenever there's more in the function itself. Okay, so we have y is equal to x for every x greater than or equal to 0, or y is equal to -2x for every x less than 0. So what interval does the -4 fall into? It falls into less than 0. So that means we put -4 into this part of the function. -2 times -4 is equal to 8. Where does -2 fall? -2 also falls in this part. So we have -2 times -2, which is a positive 4. And where does 0 fall? 0, 2, 4, 6 are all greater than or equal to 0. So for every one of those, it falls into the yellow interval. And whatever x is equal to, it's saying y is equal to that number. So for all of these, you just get 0, 2, 4, 6. So we have -4, 8, which is way up here somewhere. We have -2, 4. We have 0, 0. Then we have 2, 2. And then 4, 4. And then 6, 6. This graph is a little bit different. I'm really not good at drawing these today. Let's try this. There's one, and there's the other one. Okay, so what would the domain and range be? The domain is going forever both directions. So the domain would be all real numbers. The range is going forever this direction. So the range is going to be 0 to infinity.